All right, this lesson is on quadratic transformations. All right, when we're talking quadratic, we're talking about degree 2, so x squared. And we know that when we have a quadratic function, it's going to be some type of a parabola. But we are going to start from the parent function, y equals x squared, which is what we have going on right here. All right, we're going to call this the parent function. Take a look at that. And then we're going to see how the parent function changes when we add and subtract things to the x, or when we add and subtract outside of the parentheses, or when we multiply by a number in the front. So, but for starters, this is the parent function. Let me zoom in. Okay, this is the parent function right here. This is y equals x squared. Okay, notice how the vertex is at the origin. It's upward facing, okay? Now, let's see, what are we going to do to this thing first? Okay, so we're looking at this equation right here. We took the parent function and we added 3 to it. Okay, we went plus 3. Now, if we do that, we see that the graph has moved up by 3. It's gone like this, exactly 3 units up. On the other hand, take a look at this modification. All right, I mean, here's our parent function, y equals x squared, but now we've got this minus 2 on it. So this time, look what happened. The graph moved down 2. Okay, exactly down 2 units. So let me get this straight. When we added 3, it went up 3. And when we subtracted 2, it went down 2. Okay, now this is your k value. And because we keep referring back to this model, and so our k value is this value being added or subtracted on the end. So now it's time to generalize. So how does the k value affect the graph of the quadratic function? Well, a positive k value moves the graph up k. Okay. On the other hand, guess what? A negative k value moves the graph down k. Okay, a transformation like this is called a vertical translation. All right, now, if k is positive, the graph shifts up k. If k is negative, the graph shifts down k. All right, fantastic. Now, let's look what happens as we add and subtract inside the parentheses. All right, that's being squared, like along with the x. All right, now we're calling this the h value, because if we look back at that model, the h is inside the parentheses here. So let's see what's happening here. You'll notice we have a plus 4 on the inside, and yet the graph has shifted to the left by 4. And let's look at this one. Now here we have a minus 5, but you see the graph has shifted to the right by 5. So this is kind of the opposite of what you normally would expect to happen. Am I right? Normally we're used to thinking of positive things moving to the right and negative things moving to the left. But this is sort of the opposite of what you're used to. So just really absorb that. When it's positive 4 in here, you go left 4. And when it's when it's negative 5, you actually go to the right by 5. Okay, so time to generalize. Alright, this time I'm not going to write the answer in both places. I sort of felt silly. I wrote it out myself, and then there kind of is a space for you just to fill it in. So I don't know why there's all this space here, but this type of transformation is called a horizontal translation. Okay, that's a horizontal translation because we're moving left, right. Translation is a mathematical word for sliding across the graph, okay? Now, if h is positive, okay, like this positive 4, the graph shifts left h. Okay, if h is negative, the graph shifts right h. Okay, so go ahead and memorize that. Okay, now what's happening here? Now look guys, I want you to be careful with this. You'll see that when I have this 3 in front, okay, this graph looks skinnier, more narrow than the parent function. However, I don't want you to use that word mathematically when we're talking about what the 3 does, because that's just an illusion. All right, the parabola is not really getting narrower. What I need you to visualize is something made of rubber. All right, imagine this happy face is made out of rubber. All right, if I were to take it and stretch it vertically like this, now it's going to look like this happy face is narrower. Okay, the reality is it hasn't gotten any more narrow than it was before. It's just that it's being stretched out. Okay, so that makes it look skinnier than it was. Okay, now that's exactly what's happening to our good friend the parabola. Okay, so here is our original parent function. Now I want you to keep an eye on this point right here. Okay, now what's happening is it's not that the parabola is actually getting narrower. It's really that the parabola is being vertically stretched. Okay, something like this is happening. We're stretching it, we're stretching it, we're stretching it, we're stretching it, we're stretching it. Okay, this is what's happening. So if you look at the original graph, it looks like it has gotten narrower because the whole thing fits inside, and you can see the gap in between. But it really didn't get any narrower. Okay, the same part of the graph is just as wide as it was before. It's just that, now I told you to keep an eye on this point. As we stretch this parabola vertically, this point moved up because it was being stretched. Okay, and that point has now moved from 1 to 3. Now remember, this is a graph of multiplying by 3x squared. So it turns out that any point that you want to pick has moved up, not 3 units, but 3 times the height that it was. So if this was at a height of 1, then now it'll be at a height of 3. It's got multiplied by 3. Okay? If I had a point that was at 3 before, okay, look, well, so take this point for example. Maybe I'll do another color. This point was at a height of 4. Okay? So by stretching it, what's going to happen is that point is now going to be at a height of 12. Okay? It went from 4 to 12. It got tripled. So anyway, this is probably too much information for you, but the main thing to understand is that it's not getting skinnier, it's really just getting taller. It's being stretched. All right? Because really, if you looked at the same spot on the graph, okay, like this point became this point, and this point stretched up to this point. The width across is exactly the same as it used to be. It's not any skinnier, it's just being stretched vertically, that's all. Okay, so that was probably more information than you really needed. Now, looking back at our model, this number in the front is called the A value. Okay, so we just saw that we had an A value of 3, and that was a vertical stretch by a factor of 3. It was 3 times as big. We call that a factor of 3. So let's go ahead and record that on our notes here. So let's see. When we had an A value that was bigger than 1, the graph stretched vertically. Okay? And now let's look at what happens when the A value is between 0 and 1. So think about decimals or in fractions like 1/2 or 3/4, that type of thing. Okay, so look here, if the A value is 1/2, then what's happening? If you look closely, let's go back to the parent function once again. Keep your eyes on these points right here that start out at 4. Okay, keep your eyes on those points. What's happening is, come back to me. All right, it might look like the parabola is getting wider, but what's really happening is the parabola is it's like it's being crushed. Okay, imagine that a giant is stepping on this and pushing it down. Okay, so what's really happening now, it looks like it's getting wider, all right, because you can see all the space in between the parent function and this new graph, all right, so it looks wider, but that's not what really happened. You saw what really happened. This graph was crushed. Now, the mathematical term we use for that is compression. It was compressed. Okay, but it's like it was squashed. But we're going to use the word compression, all right, because it's a math class, we have to be rigorous. Now, if you focus your eyes on those 2 points that I wanted you to watch, this was their path. Like this point went from here to here, and same with this point. Okay, so remember what we did was we were multiplying by 1/2. So it makes sense that a value that was a value of 4 now became a value of 2 because that's half. If you look really carefully, I know it's going to be hard to see this, maybe with a finer pen. Right here we had a value of 1. Guess what? That became a value of 1/2, okay, because it was taken to half of its usual value. And you could do that with any point. This is harder to see because it's between the lines, but this is at a value of 6. Guess what? That became a value of 3 when it was compressed. All right, so every value became half of its previous value. So instead of thinking of this as getting wider, I hope you now realize that what really happens when you have an A value between 0 and 1 is that it is a compression. Okay, it's like it's being crushed, it's being compressed. So when A is between 0 and 1, the graph is compressed vertically. So in general, this type of transformation is called a vertical stretch or compression. Depending on if the A value is bigger than 1, that's a vertical stretch, or if the A value is between 0 and 1, that is a vertical compression. All right, well, how does changing the sign of A affect the graph of the quadratic function? So we're talking about, for instance, sticking a negative sign on the front of our parent function, and you can see what it does. It's turning it upside down. Now, we're going to call that a reflection in the x-axis, all right, because it was like a mirror image. It started off like this, and now it's like this. So that's a reflection in the x-axis. Okay, let's see. All right, I guess that's all there was to that. This transformation is called a reflection. In the x-axis. Okay, so that's what changing the sign does. Now, let's identify all of the transformations, okay, for the following quadratic functions. So looking at this, I see 3 transformations, okay? I see this yellow one, I see a blue one, and I see a pink one. Okay, these are the 3 transformations. Let's take them one at a time. I'm going to start with the yellow one. Okay, I better make this a little bigger. Okay, this plus 3 is going to send the graph up 3, also known as a vertical translation. Okay, so a vertical translation up 3. Now, this blue one, okay, now remember, inside the parentheses here, this will be sort of the opposite of what you would normally think. All right, so inside the parentheses will be either a left or a right translation, but -4 will actually be to the right 4. Right 4. And of course, that is a horizontal translation. Okay, and finally the 1/2 in the front, a value of 1/2. Okay, we know that because that number is between 0 and 1, you know, it's less than 1, between 0 and 1, that's going to be a compression. It's like a giant steps on the graph and crushes it, but we call that a vertical compression. And now we'll be real specific and say by a factor of 1/2. Vertical compression by a factor of 1/2. So those are the 3 transformations I see on number 5. Okay, how about number 6, you guys? On number 6, I see actually 4 transformations. Let me try to hold on. Excuse me. That was a crazy sneeze. Here are the 4 transformations. I see the -7. I see the +5. I see the 2. And then the negative sign is really its very own transformation, you guys. All by itself. I need a nice green color here. Okay, those are the 4 transformations that are happening. 4 of them. Count them. Don't miss any. Okay, so this one, okay, remember, when a number is outside the parentheses being added or subtracted, that is a vertical translation. We're talking about up or down. In this case, this is down 7. Vertical translation. Okay, so that's a vertical translation down 7. Now this blue one, all right, inside of the parentheses here, this is a left or a right motion, but it's the opposite of what you might think. So +5 is actually going to send you to the left 5, and this is called a horizontal translation. Okay, now the 2. All right, ignoring the negative sign, okay, the 2 part is between 0 and 1. All right, it's bigger than 1, if you will. No, did I say between 0 and 1? Okay, scratch that. It's not between 0 and 1. The 2 part is bigger than 1. So because it is bigger than 1, this is going to cause a vertical stretch. Okay, when it was 1/2, it was a vertical compression. It's like it's being crushed and made to be shorter. But when this pink number is bigger than 1, all right, not counting the negative sign, that's separate, then this is going to be a vertical stretch. Vertical stretch by a factor of 2. All right, that means every point on the parabola will become twice the distance, okay, twice as tall. Except for be careful, because now this negative sign in the very front comes along and it has something to say about it. Okay, remember that negative sign, you know, we could say it's going to turn things upside down if you want. All right, it's going to take it from being like this, all right, to all of a sudden being like this. But turning a graph upside down is called a reflection. A reflection in the x-axis. Oh, I'm supposed to be doing green now. Reflection. Reflection in the x-axis. And there you go. Was that the last problem? I think that was it for this lesson. All right, I hope this lesson was helpful. I hope you learned something. Glad that you even took the time to watch it. I will see you on the next video either way.